Hey everyone, welcome back to Software Testing and Quality Talks by Venkat Ramakrishnan. In this episode, we are going to talk about log4j vulnerability with Sylvia Killinen. Let's go. Hey everyone, log4j open source security vulnerability was detected around December 2021, second week, which is putting hundreds of millions of devices under risk and have brought cloud services of a few providers to their knees. What is this log4j vulnerability? I have with me today Sylvia Killinen, who is a security testing specialist. Let's discuss about this with her in detail. Hi Sylvia, welcome to Software Testing and Quality Talks, and I'm glad to have you today to discuss about the log4j vulnerability. It's a pretty important topic and the industry has been buzzing about it for the past 20 days or something. So it's great to discuss this with someone who is involved in the security specialization. So welcome to the show.
Thank you very much. It's great to be back, and you have sure picked a great topic.
In terms of educating the audience about this log4j vulnerability, could you tell us a bit about what exactly this is and how does it work?
Sure. So this is a really tremendous vulnerability. Every time you install Java, you'll see that screen saying Java is now run in 3 billion devices worldwide, or something similar to that. And, well, that is now a threat, because almost every device that uses Java uses the standard logging library log4j. Now, that's great because it means that they all log in a very similar way, and you can pull all sorts of data out of your system in a consistent and approachable sort of way. Log4j is a library that's maintained by volunteers, and it's a really pretty great piece of software. Unfortunately, it also evaluates statements that are placed into the logs before it actually writes them to the logs. That's the cause of our vulnerability right now. So if you were to say, it's a JNDI statement, JNDI, you were to say JNDI lookup local password, it will actually evaluate that password as part of the statement to be logged and write it to your log.
Wow, that's interesting, because to me, logging is a pretty harmless thing. Logging is pretty useful for devices to keep track of what's going on in them and how to make sure that things are, devices are performing in the way that they are expected to. But from what you say, the statements are getting executed or kind of evaluated before the actual log message is getting written somewhere. Is that correct? Is my understanding right?
You're exactly right. And the way this becomes a little less harmless is when you craft a statement to say, take that local password and connect out and give it to me instead of writing to the log.
Okay, come again. I didn't get it.
To truly exploit this, not only do you need a way to control what's written to the log, you also need a way to make the computer that would be writing to the log talk to you instead. You have to have an outbound connection.
Okay, so that's going to be a two-way connection that's happening between me and the application that is writing the log somewhere.
Exactly. So once you've controlled it, once you've injected that statement, you need the server to call back to you with whatever piece of data you've created or queried using the log4j library. You can do that connection in a variety of ways. Doesn't matter if it's HTTP, WebSocket. You could probably get a little more exciting with it if you had something custom. But the truth is, you don't need to. You can go very basic and it will be just fine.
So how do I get access to a server that is writing the logs?
Well, through that vulnerability. If you can control what is being written, and consider that many web applications will log every query that is placed into them. Many APIs will log the strings that the user wants to run just for troubleshooting purposes or to monitor how the service is being used. So it could be as simple as injecting that statement into a field that you have full control over, such as the username or something a little more hidden like a user agent string. There's actually a library of such strings out there on GitHub, and I'll send you the link to that because it's a very interesting read.
So what exactly is JNDI?
So that is the Java Naming and Directory Interface. It's essentially an API within Java that allows you to use various functions of the programming language. Just because of the way Java applications are structured, if you have a jar file, that being your compiled Java file, it can contain other jar files.
Okay.
So even if you look at your Java application and say, oh, there's no log4j here, we're fine. It's also wise to check your application's dependencies because it may bundle something with it that includes log4j.
Got it. So the standard way of looking for dependencies would be to check the software bill of materials, correct?
Exactly. That's a great way to do it.
Okay. But there looks like there are multiple ways and multiple formats of SBOMs involved. There is no reconciliation between the different groups that are doing this. Do you have any thoughts on the SBOM and how it can be effectively used against this vulnerability?
Well, I'm really not concerned about which one someone is using, more that they are using one at all or that they have some similar tool. A bill of materials is definitely helpful, but it's not the only way to detect what's going on in your software. If you have any means of detecting dependencies, whether that's software composition analysis or SCA, whether it's your bill of materials, or whether it's even a manual scan, although that can be very tricky and very time consuming.
Okay. From an end user perspective of an application, right? For example, if I download an app in my Android phone, how do I know that, this application is safe? How do I know that I'm not vulnerable to the attack?
Boy, that's a good question. At this point in time, if you're running a Java application and you have access to the source code, it may be interesting to look at it. Now, that said, I think I know one person who does that for all of the software they run. Everyone else pretty much trusts software at some point. If you want to dig into it, there are also lists of known vulnerable software, and I'll send you a link to that as well. But if you're assessing something yourself, there are several really good articles out there. Cloudflare wrote one, for instance, and I know there are others that will teach people how to detect whether a vulnerable version is in use.
Okay.
Right now, one of the rules of thumb is if it's a 2-point-something version and it is less than 2.17, it is vulnerable to log4shell.
Okay. And I'm pretty sure that people who are using the apps from the mobile devices are not going to be knowledgeable enough to find out which version is running or not.
I think that's a valid statement. If somebody is just running software and doing their own thing, they probably don't want to be doing code reviews. My advice at that point is patch everything.
And even patching is not in our direct control, I guess.
Perhaps not. Not always.
We get the patch only when it is being released by the app developers or by the phone developers if it's a major patch that is getting released by the operating system, but that's also not in our control. I'm pretty worried about this scenario where we don't have control on the security of the applications that we are using. As a developer, what are the steps that you would recommend that I should take in order to avoid this?
Well, you would need to make sure that your application is running the latest version of log4j. If you cannot do that for some reason, you have a couple of options. One of them is turn your logging off.
Wow, okay.
I know that sounds really drastic. On the other hand, if it comes to the choice between I can't read my logs until I can do an upgrade, which is now my top priority, and I can't tell if my server has remote commands being executed upon it, I'm going to take the lack of logging almost every time. Depends what that server is doing, of course. If it's something very critical to be logged or something with a regulatory requirement, that's a bad choice. But if it's not one of those situations, maybe just turn it off until you can fix it, and then prioritize the fix. The other option is to make sure that your server can only call outward to known endpoints. Now, this may not be possible if you are, for example, running a web application. But if you say, I only ever talk to a handful of endpoints, I only ever should be calling 30 different IP addresses, if you have access to a web application firewall or some similar network level control, you can stop your server from calling anything but what it absolutely must. If you do that, you stop the exploit.
Yeah, that sounds like a sensible thing to do if we have the choice to do it. So coming to the security testing perspective, security people all around the world are quite busy with this particular thing. I heard that many of the people in the site reliability engineering as well as customer facing roles are having a very hard time, especially towards the end of the year, tackling this particular issue and working hard to make sure that their systems are safe. From the security testing perspective, how do I make sure that I test this effectively? How do I check whether there is no vulnerability, or even if there is a vulnerability that is effectively detected and reported to the management so that that is addressed in the proper fashion?
Well, I think the best way for a tester to address this is to work with your developers and work with your information security department or your contacts in either of those areas. First, check that bill of materials or check your software composition analysis reports. Find out if a vulnerable version is in place. If it is, the great thing about being an internal tester is being able to tell what's written to the logs. That's where you ask your developer, what are you logging?
Okay.
And then you look at all of the things the developer is logging and see which of them you can control.
Okay, instead of asking the developer what they are logging, is there a way to find out myself as a tester?
Definitely there is. That's really the easy route and the most collaborative way to do it. A slightly less cooperative way to handle it might be to take some of these strings that you know are likely to work and throw them in every single input you can. This would be more like a fuzzing approach. You're taking a lot of inputs and you're just throwing them out there to see what happens. Now, this does rely on you being able to check the log. If you can't check the log yourself, that's when you start needing something to call back to you, and that's when you get a little more penetration test and a little less functional test.
Okay. Could you please elaborate a bit more about what you just said? It's getting interesting because it has a lot of commonalities between what we talked before in terms of security testing and what we are talking right now.
Yes, definitely. So this is the process we discussed before of first finding out what those inputs are and what the valuable thing is that you want as a security tester to remove from the system, or what behavior you want to inject into the system. Once you know what that is, in this case, it might be something like stealing a password off the server or getting some information that you generally should not have through the software's normal operation. Once you know what that is, you can start writing your query for it. Once you've written your query for it, you pass it to the server and you see if it comes back. From there, it follows a fairly standard exploratory testing procedure. You analyze what you've got, and you tweak it as you go. If you want to try this, there is a website called tryhackme.com, and they do have a log4j exploration module that explains the vulnerability and explains the steps. TryHackMe allows you to stand up a VM in your browser, and you can play around with that system for, I think, an hour per session if you have not paid them for it.
Okay.
There are other websites that do very similar things. I don't know who all has log4j modules at this point, but I'd be surprised if there were not at least a few available by now.
Got it. What is this log4shell? I'm hearing something else called log4shell. How is it different from log4j?
Log4j is the name of the vulnerable library in Java. Log4shell is the specific name of the exploit.
Okay. And do you think monolithic applications are safer than microservices to avoid this vulnerability?
No, not even a little bit. Any application that is written in Java very likely includes log4j somewhere within its dependencies. I don't really think the architecture of the application is going to make a tremendous difference. If it has inputs that a user can control and it can call back out to wherever it wants to, there's a good chance it's vulnerable.
Okay. So just curious, why is it becoming a big issue right now? I mean, why is it not detected all these years? It has been there for past 25, 30 years right now, right?
Right? That's an interesting question. And I don't have a good answer for you, especially something used so widely. I do know that somebody came up with either a very similar or an identical log4j bug at a DEF CON talk in, I believe, 2016. This has been around for quite a while. Now, if the question overall is, how come some software bugs don't get detected for 25 years? I think any tester can tell you that sometimes things just get away.
It's not about things getting away. It's just that it's basically a architecture level issue that we are talking about, right? This is a pretty obvious, pretty simple thing that anyone who pays attention to the software architecture will be able to find out. It's a pretty simple thing. Why are people who are good at Java, good at architecture, good at logging, etc., we're not able to find this all these years is my question. I mean, it's not about whether it was detected or not, but why was it not thought about before is my question.
I'm pretty sure it was. Again, we heard about this 5 years ago, and my apologies, that was a Black Hat talk, not a DEF CON one. I just sent you the link to that as well.
Okay.
But there are quite a lot of bugs that are found well after one might expect. Some coworkers of mine actually just found a few of them. I'm trying to find the link to that as well. You may have heard about a hack of a bunch of Netgear Soho devices. That's the same sort of thing. It was a lot of bugs that have been existing in the wild for many, many years. And when they were released by my team, it was still quite a surprise.
Wow. So basically, it all boils down to code that was written long back, and people were not thinking about how these things could be misused. Is that what it is?
I think it's the same as any software bug. We work with very complex systems. And sometimes the ways they interact and the ways they fail are non-intuitive. Even when we do our best and think very hard about them, sometimes things get through, and they aren't always discussed or discovered in a quick and easy manner.
Okay. Let's talk about the fix that is being offered in this upgrade. So what is the fix exactly?
So as I understand it, the fix is a patch of log4j to remove a vulnerable library. Now, I haven't looked in great detail at the log4j 2.17 patch, which is what we need to be discussing at this point. The version that made all the headlines was 2.15. They released, and by they, I mean the log4j team, who reacted incredibly quickly and professionally to this. They released 2.16 in, 3 or 4 days?
Mm-hmm.
It was almost immediately found that 2.16 did not resolve the problem. There was another issue that presented another remote command execution bug, and they turned it around in another 3 or 4 days and released 2.17.
So basically, when you say it patches the vulnerability, so you cannot basically avoid injecting something. So what exactly does it do? Because basically you can't prevent the same sequence of actions that user can do to make the system vulnerable, right?
Yeah, you can't guarantee that nobody's going to send you bad traffic. But again, I have not looked in detail at 2.17.
Okay.
You can upgrade it. You can control your external traffic.
Okay, got it. So it doesn't look like there is a magic pill that's going to solve the problem. It all depends on how you design the system, what kind of input output parameters you are looking at. And so it's going to be a sequence of actions or operations that's going to make this go away, rather than some magic fix that's going to solve the problem, as I understand it.
Yeah, it would be a difficult one to wave a wand to make it go away. I think you're exactly right there.
Okay.
One of the things that's important to keep in mind is this vulnerability has been known only for a little over a week now, getting close to 2 weeks, but it's still very new. This situation is changing by the day.
Okay, got it. So what is your opinion on this being in the open source rather than being in an enterprise control?
I think it depends on your risk tolerance and what you want. If you're trying to say, I will not run anything with open source components,
I'm
good
not
luck.
saying that. No,
I hope your
not.
SCA is very, very good.
No,
But
I'm not saying that.
there may be a legal obligation for a corporate developer to release a patch or to resolve a bug, but it won't stop them from happening in the first place. It sure didn't save SolarWinds. And on the flip side, an open source library may be able to patch very, very quickly and may be able to attract a lot of eyes and a lot of testing. The log4j crew has certainly attracted the attention of a very many open source developers and testers.
Mm-hmm.
They are definitely riding the tiger right now, and much respect to them. What you choose to run in your own environment is going to depend on your risk tolerance, and I can't really give you a blanket proclamation about that.
So this vulnerability, is it happening on the server side or the client side of the application?
The vulnerability exists in, well, it depends what is being exploited. If it's a web application that is logging usernames, it's on the client side because the client controls that. The client controls that entire interaction. On the other hand, remote command execution is going to happen on a server pretty much exclusively. So the answer is yes.
Yeah. So on next steps, where do we go from here? So we apply the patch, and then should we be looking at how we design the applications in the future? What kind of precautions can we take in addition to what you already described as a developer thing? Is there anything else that I can do in terms of doing the architecture for the system?
I think what you're asking is, how do I avoid writing bugs into software? I don't think we can.
No, that's a fair ask. Because all we are trying to do is not to have the bugs at the first place, and we are trying to avoid or prevent it from happening. And that's okay. We will try our best from that happening. But of course, we cannot avoid it totally. And that's what the post-code testing is all about, to make sure that we detect all the things that we did wrong and try to address them at that point. But even pre-code architecture, design, analysis during the code are also important to prevent or avoid the bugs from happening.
I would definitely agree with that. If you focus on resilience and detection and repair rather than perfection, I think you'll have a much better time of it. Test early and fast and often is what I would say. Detect unwanted behavior as early as possible. When you do detect something, respond quickly and with intention. I've heard it said that something like 90% of security is operational excellence. I believe that. Assess your architecture, test during your development, test after your development, and respond quickly when you find things at every level.
All of them?
All of them.
Okay.
The more you can test early in the cycle, the more problems it will save you.
Yeah, that's always the case, right?
But that's no reason to stop testing later in the cycle.
So let's say we detect something in the production and they wanted to fix right away. I know that people are working really hard to give a fix in 2 or 3 days. How difficult is this fix?
I don't know. It's going to depend so much on the system in question. If you have something where the vulnerable library is in your application in one place and you know where it is, maybe you can turn it around really fast. If you have something where the vulnerable library is in multiple locations and all of them are multiple dependencies down, you're going to end up. I suspect the latter is what a lot of people are dealing with. Not necessarily one vulnerable copy sitting right where it's nicely labeled and known, but multiple and scattered all over the place. That's why this is hard.
This is a pretty important topic, and people are working really hard to get this fixed. I'm pretty sure there'll be a lot of further discussion from several sides. Several companies are trying to address this from different levels, in addition to the patches that are being provided in the open source. And there is a lot of interest in the community, and there is a lot of interest in the industry to talk about it, and I am hearing a whole lot of discussions happening at different levels, which is good. So let's all hope that this gets fixed and people and systems are safe, and we don't encounter any kind of issues in the future because of this. It's really, really scary. As far as the security is concerned, it's double-edged sword, I think, because when you try to create awareness about something in the community, it could also end up the information being in the wrong hands. So we got to be really careful about what we are talking about. So that said, all the information that you have provided is very useful. I will go through the links. I'll also try to share this in my podcast. Testing at all levels and also be vigilant of what's going on is really important, and we have to keep our eyes and ears open on all the stuff that's happening, which is going to be beneficial for everybody. Now that software is ubiquitous and it's available everywhere in every form, it's really important that we make sure that it is secure and safe. Thank you so much for your time talking to me today, and it has been a pleasure as always to talk to you on the security topics, and I look forward to speak to you soon on another security topic.
Looking forward to it. Thank you again. Have a great time.
Have a great time, you too. Bye-bye. Thanks.
Bye.
That was an awesome discussion about log4j vulnerability with Sylvia Killinen. We thank Sylvia for her time discussing this with us on Software Testing and Quality Talks YouTube channel by Venkat Ramakrishnan. I'm sharing the resources that Sylvia mentioned in the show right here. I'm pretty sure these would be very valuable to you to explore more about log4j vulnerability and use those resources in your work. What are your thoughts on log4j vulnerability? Do you have any questions? Please comment in the comments section of this video. Sylvia or me will reply you back. Also, don't forget to subscribe to this channel by clicking the subscribe button so that you get to know about the latest and greatest videos on software testing and quality in Venkat Ramakrishnan's YouTube channel. Until next time, ciao.